Yeah, you
Yeah.
need. Okay,
Okay.
yes, the name is already said. Good.
Yeah. Okay. So let's begin. So
It's a notification that recording has started.
yes, you should have gotten
Okay,
that by
good.
now.
All right, yeah, it's
Okay.
on. Continue.
Okay. That's good. Uh, um. Yeah. So you often hear about shell, what terminal, command line, prompts. For most people, these are new terms, right? So just as way of explanation, what you're looking at is a terminal. This is a terminal. It's an application that displays stuff. The terminal, right? But it's also the command line. The command line is an interface for you to interact with your computer. You send instructions to your computer as text. You type them in, and usually you hit enter to send them, and you get some response. So that's why it's called a command line. You type a command, for example, if I type ls, I'll get a list of the 1,000 directories in this directory. Right? So that's why it's called the command line. The prompt is the information that is displayed to you constantly. Right? So this is part of my prompt. This is part of my prompt. This is my prompt. Everything here is my prompt. Well, I mean, the viewport for me to interact with the kernel is my prompt. So this application is a terminal. Also, this is the command line. And the shell is what I'm interacting with. In this case, is bash. If I were to do echo shell, tells me bash. This is the bash, the binary for the bash shell. So that is what the shell is. In this case, it is bash. It is the most popular shell for Unix-like OSs. Right? So in this case, Ubuntu, it is bash. Right. So working from the command line, which is what we're here to do. Why do you work from the command line as opposed to working from the graphical user interface, which is what you are used to for most people? Working on your Windows, Mac OS, or Linux computers, you are used to working from your, lack of a better word, the desktop, right? So most things you do on your desktop with your mouse, when you click an icon, actually under the hood, this is happening. Your shell is your GUI is the shell itself. It's actually sending commands to your kernel the same way you're sending commands yourself. So working from the command line is a faster, more granular way to do things. Right? For most people, this is not important, right? But for people who work with computers, it gives them some advantages. There are things you can do from the command line that you cannot do otherwise, right? So, yeah. Just as a way of explanation, I want to explain to you that most things you do, operations you do from the command line can be done from the GUI and vice versa, right? So, let's say I want to create, let me put CD into my desktop directory, desktop, right? So if my ls, there's no file in my desktop, so ls returns nothing to me. If I had to go to my desktop, it's clean except for my trash. If I had to create a directory here, let me say create a new folder, right? I name that folder tests. There's now a directory on my desktop. If I had to go back to my terminal and I did ls now, you see that that directory now shows up here. If I go into that directory, I have to create a file, say touch, let's say test.txt. If I had to go back to my desktop and I open this test directory, you will see the file there. So you're doing the same thing from two different shells. So your graphical interface is one shell, your bash from your command line is another shell. So that's often how you do things. Since you can do from your shell, you can do most of them from your command line, you can do most of them from the user interface, graphical user interface, and vice versa. But they do them in slightly different ways. So, for example, when I go into this directory, at a glance, the information is presented to me. I could just look into the directory and I could then see the files that were in the directory. In this case, just this one. But in your terminal, you have to, when you go into a directory with CD, you then have to run a command to tell you what files are inside. In this case, I have to do ls to see if there are any files there and what they are named, right? So you have to slightly modify how you work with your computer when you work on the command line, because information is presented differently, and sometimes you have to actually go to look for the information yourself. But essentially, it is the same thing. You can create a file, you can edit, same way you can edit this file, I can edit this file, say open text editor, and I can add some text inside, and I can say, hello, my good friend. Right? And I could then save the file. Say, let me save this, save the current file. If I went back to my terminal, I could then say, okay, let me use nano to open this file, nano test.txt. I will see the text here, hello, my good friend, and I could then say, okay, let me say, just move this and just leave hello in. And I could then save it. I went back to here. It won't update. So if I was to do close this, right? You see, it has changes from 30 seconds ago. I say close without saving. But if I was to go back here now and open this file now, you see that the changes are now reflected. So you can manipulate files the same way you would do from your graphical user interface. You can do them from your command line, right? I hope this is clear. Anyone who doesn't understand anything, please feel free to unmute and contribute. So yeah. So Nano might be new to you, but it's just a text editor like Vim and or Emacs, right? I don't have Emacs installed on my local machine, but I have Vim, a different kind of Vim. But if I also go to my sandbox, get it closed already. Yeah, I'll open this again later. Well, it's just a text editor, just like those ones. Yeah. So this is the environment you're supposed to work in, mostly for the rest of the program, right? Eventually, you might learn to use other tools to do some things, whatever suits your workflow best. But for the purposes of the program, you're supposed to do your work here to code, test, and even deploy from this environment, right? So yeah, and that's the broad strokes of the command line. It is just another way to interact with your computer. It gives you, for a technical person working with computers, it gives you more control over how some things are done. It gives you access to some things you can't do from the graphical user interface, and it's also faster, right, for working from it. Then if you work with the programmer, you work with text, and working with text in the text-based environment kind of makes sense. It's the old way of doing things. There are different ways of doing it now, but we still cling to it for some reasons, right? Yeah. So I think if I've mentioned anything you don't understand at this point, please feel free to unmute and mention that. Yeah, but if everybody is on understands everything so far, let's move on to stuff. So yeah.
Mr. Adewale, good evening.
What? I can't hear you. Please
Can you,
speak up.
okay, can you hear me?
Yeah, I can hear you now. Yeah.
Okay, good evening, everyone. Okay, my question is, what is your view? Is it also possible with Windows, Windows command prompt or Windows or PowerShell?
Yes, if you work in a Windows environment, you can do this with the caveat that you can only do it with the applications that are available for you on Windows. But if you open PowerShell, you can open apps and files. I can open applications. For example, I can open my music player now. I can say I want to open Rhythmbox. This kind of Rhythmbox. Yeah. So if I do this, it will trigger my music player, right? So you can do the same things in PowerShell, right? You can do that in PowerShell.
Okay.
The command line is just whether you're using Windows or you're using Mac, or you're using Linux or FreeBSD or whatever operating system you're using, a command line is still a command line. The language, the shell is different. For example, Bash is the shell we're using here. But if you're on Windows PowerShell is PowerShell. It's a shell, right? So the commands might be slightly different. The way they handle things might be slightly different, but it's the same concept. You are typing a command into the shell. It is taking that, passing it to the kernel, doing something, and giving you some usually, but not always giving you some feedback, right? So yeah, you can do that. You can do these things, most of these things in PowerShell as well. Yeah, but it's with the caveat that it's the different environments and things might work differently, right?
Okay.
Yeah.
Thank you very much.
Yeah. Okay. So when you're working in the shell, the command line, the first thing to learn, I think, is the file system, right? And the file system in most Unix systems, but particularly in Linux, is an inverted tree, right? So it starts with roots. If I cd to my roots now, and I do ls, you see when you log into your sandbox, you see something like this, right? This is the roots of the file system. Every file, every directory starts from this place. You trace the absolute path for any file or any directory, it starts from roots. So it's like a tree that is upside down, right? Instead of the roots being the bottom, it's at the top, right? Or if you want to see it, that's how I usually view it, but it's the same way. Every file starts, the path for every file starts on the roots, right? The absolute path for every file starts on the roots. So in your roots directory, you have these different directories. There are no files here, right? We have these directories. Bin is where you store your binaries. Binaries are your applications, what you run, right? Boot is where the files are set up. You set up your computer. The boot files are here. CD-ROM is self-explanatory. Dev is for devices. We'll come back to that later. etc is for text files. It's text configuration, right? The files that define how your applications work, your config files, they're usually in this directory. Home is home, right? That's where if you do try to ls home now, this is my user. So my user directory, my home is root/home/slim. Lib and lib32, they're for library files, right? For these four, right? This 32 bits, 64 bits, x32, lib. They are usually same linked to each other. Lost was found is for files that they've broken in some place, they're kept here and recovered. Media is self-explanatory. MNT is mounts, is where you add, if you add, say, an external flash drive or like SSD, this is where you'll be found. OPT is for optional files. You install an application like, say, VLC or maybe VS Code, something like that. They are not system files, but they are application files. They're usually saved. The binaries and their config files are usually saved here. Proc is actually process, so it's like a directory that houses log files and stuff like for processes. Root is root is roots, and run is something similar. We'll come back to it later. SBin is for special binaries. It's a counterpart to this directory, the bin. This is a personal directory that I added here for an application. SRV, we'll come to this later. CSC system, time shift is an utility. You probably won't have this in your environments for backing up your system. User is not actually user, it's Unix system resources, but say it's user now. TMP is for temporary files, and VL is for variable files. That's files that change depending on what you're running in your system. Right? TMP is for temporary files. After the files here, they're short-lived. They don't stay there for long. They're just temporary files that your processes and applications need to run. Right? So this is basically your file system, where it starts from. This is your roots, right? So one thing about file system is that everything in Linux is a file, right? It sounds funny, but that's how it is. So let me talk about stuff like the file path. So for example, if I were to cd into home and slim, this is my home directory, right? If I were to ls here, you'll see this, right? So if, for example, I did pwd here, right? This is the path it gives me. This is an absolute path because it starts from the roots. This path, if I was to read this to someone over the phone, I would say root/home/slim, right? It's an absolute path. Any path to a file or directory that starts from roots, that starts with the / is considered as an absolute path. Then you also have relative paths. Say, for example, I went into a repository. Say I went to GitHub, ALX, tracks, SED, 0x15, right? So I was in this directory now. I was doing something with APIs, and I wanted to go somewhere else. If I do pwd here, you see, this is an absolute path to this directory. It starts from roots, goes into home, goes into slim, goes into GitHub, ALX, tracks, SED, and this directory. And there are files here as well, right? So there are Python files to do something with APIs, right? Yeah. So this is an absolute path starting from the roots. But if I wanted to go, for example, say, I wanted to go into this directory, the parent directory for this directory, which is SED, and then go somewhere else. I could just say, for example, I could say something like this. I could say cd, and I could start from the beginning. I could say cd /home/slim. I'm going to GitHub. Then I say I was going to ALX. I'll go to tracks. I'll go to SED. Right? That works, right? But at the same time, let me just go back here. Right? Back in APIs now. I could just say cd ... Right? You see, it takes me to the same place. SED. This is an example of a relative path. In Linux, ... means the parent directory of the current directory. Right? That's just an example of a relative path. I'm passing an argument to cd, but I'm not passing the full path from the roots. So any path that does not start from the roots is a relative path. I could say I wanted to go to, can I just I do the same thing to go to the parent directory of SED now. If I to ls here, I have other directories here. And I wanted to go into, let's say I want to go into LLP now. LLP, right? And I check the directory, there are files here, and I say, okay, I want to go into hello world, rec0, hello world. Yeah, so I'm in this directory now in the LLP repo, and I want to go somewhere else. I could, of course, cd and pass the absolute path to the file or directory. In this case, I have to go from root, I say /home/slim. In this case, I want to go to my tests, right? It's C, so I want to go to tests, and I want to go to my C directory. Right? I could do this, and it will work. I mean, test now /C, and if I do ls, I have C files and directories here for my test run and test working with C. But also, to come to this same place without passing the absolute path, I could have done something like this. cd it's not the most elegant way of going about it, but you can do this. This means parent directory. I would come here. I could then repeat this by jumping back here, back here, back here, until I was in my home. So I could do, if you count, this is 1, 2, 3, 4. So I could do cd again, and I'll be in my home now. I could then say tests, this is correct. Hold on. 1, 2, 3, 4. Okay, I'll need one more. And I could then say tests. Let me just see what it takes me first. Yeah, in my home. Yeah. So I could have then put tests as an argument for this and move there. Let me just locate that. So yeah, we then put tests and C, right? And it takes me to that directory. This is an example of a relative path, right? The path does not start from the roots. So as you tend to work in environments, you learn the relative paths to files based on that. The relative path is relative because the path is not standard. This is always standard, right? It doesn't change. But relative path, it changes based relative to where you are in your file system. That's why it's called the relative path, right? I hope you guys understand. If you don't understand, please feel free to unmute and ask questions. It's a PLD. I'm supposed to chip in, right? Yeah. So there's also a short cut. This tilde sign. This tilde sign, if I do now, if I do CD tilde, it will take me to my home, right? So I do PWD. I'm in my home now. This tilde sign represents this expression. It represents root /home / the user's home. So when you see something like this, back to CD, back to the space. Anything you see somewhere like something like this, CD, this, so I'm going to go to GitHub again, right? And I'm going to go to ALX, tracks, HLP now, right? Even though this doesn't start with a / from roots, it is still an absolute path because this expression is equivalent to this. So you can substitute this for, in this case, root / home / slim, and then it completes the remaining / GitHub, right? So this is still an absolute path. So if I say hit enter now, it will take me to this directory, which is the same as doing this. So I go back to my test. It's the same thing as doing CD home / slim, GitHub, ALX, tracks, HLP. Right? So learning to chain directories together like this doesn't come easy at first. You may find yourself doing it step by step, right? If I wanted to go from here somewhere else, I could say CD ... I'll go one level up. I will go CD ... You might find yourself doing LS if you don't know the path too much, and you do CD ... and you do LS again, right? And you CD ... and you do LS again, right? And you CD ... get out typo, yeah, CD ... and you do LS until you find yourself, maybe you're doing PWD, right? Find yourself somewhere you know, or you see files that you recognize. It will take a while for you to be able to chain commands together like this. But the logic is the same. Right? Whether you're doing everything in one step or individually, it is still the same thing. So yeah, that is basically the file system and moving around. So that is shell navigation. Shell navigation is basically moving from one point in your shell to another. And you do this with the CD command. CD stands for change directory, right? It's a built-in to your bash shell, and you pass an argument to it, a parameter. So an argument is something that you pass to a command. Say, for example, let me create a file here. So if I do ls now, let me clear this. Right? If I do ls, there are no files here. But if I want to create a file, let's say touch test, right? If I do ls now, you will see tests. So I want to delete something. The command to delete is rm. I say I want to delete tests. So in this case, rm is the command and test is the argument. I'm passing this to this command, and I'm saying this command should act on this file. In this case, rm is delete. Delete will act on this file and delete it. Right? So if I do that, the file is gone. So yeah, after you've understand the basics of shell navigation, moving from directory to another, the next thing is usually moving files or copying files from one directory to another, or even the same directory, right? You want to make a copy of a file, you want to rename a file, which is done using rename, using MV, right? So yeah, when you shell navigation is basically about just 3 commands. PWD, which is for your present working directory, tells you where you are at any time in the shell. CD is basically just how you change directory. You change directory, you pass the parameter to it, it will take you to that directory if it exists. And you can do CD without any argument, it will always take you to your home directory. So if I was to go back, CD hyphen will take you back to the previous directory, right? If I do this now, I'm back here. If I want to go to my home, all I have to do is type CD. No arguments, it will take me home. Doesn't matter where I am, this command CD without any parameters will take me home. Right? So that's the basics of shell navigation. It's basically navigating your shell, moving from one place to another to do whatever you want to do. So the next thing is handling files. Also, file manipulation. Right? So file manipulation comes in two broad aspects. Can you guys hear me? I'm not hearing anything. Nobody's asking questions. Nobody is asking for clarification.
Yeah. I'm hearing.
Yeah, so are you following?
Yeah, I'm following.
Okay, that's good. Yeah. So another
So I don't know if they are aware they can pause and ask questions. So let's just inform.
Okay, let's give them a chance. Okay.
Yes.
If you have
it's more
questions, observations, it's a PLD, it's not a lecture.
Exactly. It's not a lecture that you are attending. This is a peer learning discussion. So once you are here, it is not like how you went to watch a YouTube video and you probably didn't understand everything. This is where you flesh out all the challenges you've had with the tasks that you've been doing and all of that. Okay, that's the essence of the session. So do ask all your questions. And also, I mean, as he's going, the new things you're learning, pick them up. If you don't get anything, stop him and ask him. Okay? Thank you all.
Thank you too.
Yeah, so the third command you need to help you ensure navigation is ls. I think we are familiar with ls. ls stands for list storage. Just tells you the contents of a particular directory, if any, right? So so next thing you want to do is handling files and working with files and directories, right? You have like everything in Linux is a file, so eventually you find yourself working with files and directories, no matter what you're doing in Linux, right? So I think for this part of the commands you want to use are touch. Touch creates an empty file, right? Creates an empty file. So if, for example, if I were to do touch, let's say, what's the word I'll use? Let's touch test.txt in this case. Right? If we were to cut this file now, test.txt, it's empty. Cat doesn't return anything to you because it's an empty file. That's what touch does. It just creates an empty file, and then you can then copy this text to this file or redirect text to it from a command or whatever. But touch creates an empty file. And that's the first thing you need to learn about file manipulation. You can create an empty file with touch. Touch also has you can do that thing with touch, but at this stage, that's what is important to you, that you can create an empty file with touch. CP is the command to copy, right? So have touch an empty file here called text, right? If I were to do ls test.txt, it's here. If I were to do ll is ls minus, I think, a, right? Or minus l, sorry, for this file, right? It says this is file, this is permissions for the file. It has read and write for the owner, read and write for the group, and read for anybody else, right? It's in this directory, and this directory is my home. Right? I could do two things by using CP. More than two, but at this stage, two things. I can make a copy of this same file here. I can make, say, CP test.txt. I can name it test2.txt. Right? We're to do ls now. You now have test and test2.txt. We're to cut test2.txt now. It's also empty, right? It's an exact copy of this file. And if there was any text in this file, it will be in this file as well. And I can demonstrate that by doing this, say, nano test.txt. Right? And let's just say hello. So if I was to make, yes, please. Okay.
I want to ask what's the difference between tag and echo, like when you want to create a file. Can I also use echo instead of?
Okay, echo is just a function that prints, right? So if I say echo 5, it just prints 5, right? So you can't use echo to create a file. Echo just prints text. What you're using to create a file is redirection. So I can now say echo 5 and redirect the text to a file. Let's say 5.txt. Right? And I cut that file. 5 is inside. So it is not echo that creates the file. It is this redirection. And then sending this text you're echoing so into this file. So that's redirection. That's a little more advanced operation. But just to answer your question, it is the redirection that creates the file, not the echo. Echo just prints text. All right?
Thank you.
Yeah, so touch creates an empty file. That's what it does. Echo prints files to the standard outputs, like I actually showed here, right? If I do echo anything, it's printed here. So I cannot have that text, instead of printing it to my screen, I cannot redirect it to a file. This is what redirection does. So this is what creates the file, not the echo command. Right? So you can also use cat to do this. So I can do, for example, I can say cat 6, right? When I say cat 6.txt, right? When I hit enter, it opens the buffer to me. I can then type anything I want to do. So I can say this is a file created with cats. Right? When I want to close this, I just do EOF. Right? And what's not doing? What did I miss? Okay, hold on. Sorry, like cat 6.txt, you know. Okay, I didn't start with EOF. You have to do cat EOF. Right? To your file, I think. It's been a while since I used this. Okay, so I think you have to. Interesting, I can't remember how to do this. Yeah, so this is how you do it. You then echo your text, say another file created with cats and EF. Okay.
Hello,
So
hello.
yeah, yeah.
Hello. Oh, sorry,
Yeah.
sir. The thing is, you see this command we've been using,
Yeah.
RNG, LX, right?
Yeah.
Basically, are they the same thing with Windows? Because I see similarities. They are not.
They are similar, but they are not the same thing with Windows, right? Windows is a very different operating system from Linux, right? So
Yeah.
Windows has these commands as well, but they're not the same. Always not the same, but they do the same thing. But they are usually named something different, right?
Yeah, I noticed that.
Yeah. Yeah. So that there's a reason why ALX wants us to use everybody to use the same environment. In this case, Ubuntu 20.04. So you have a uniform environment, and everybody's command spoke the same way, right? Does that make sense?
Yeah.
So yeah. Okay. So that's just how it. So if you do cat 7.txt now, you will see the text you created, right? So that I'm just explaining that it is not cat or EOF that creates these files. It is this redirection operation that creates the file, right? So let me try this. Yeah. So back to file manipulation. There are multiple ways to write text to a file, right? I've showed you 2 ways now. Plus, you can just create the file. For example, there's no file. If I do ls, it's just 5, 6, 7, and test. For I to create any file now, I could do nano. Let's say call this one 2.txt, right? And I could then type whatever I want to type. It say this is a file created with the nano text editor, right? I could save this. I could also cut the file now, right? So you can create text in different ways. You can use an application like this. I'm using Nano as a stand-in for Vim because I have my Vim set up a different way. So if I open my Vim, it will be different from what you know. So I don't want to confuse you. That's why I'm using Nano, right? So yeah, you can redirect your text into it from echo, printf. You can use cats to do anything, right? So there are different ways to create text files, right? So you find whatever way works for you. The ideal way, if you're writing scripts and programs, is to use a text editor, right? So you can use a place of nano. Please mute who is speaking there. You can use nano. In case of nano, you'll be expected to use for ALX purposes to use Vim or Emacs, right? But this is my standing for my local machine. Yeah. So the other command that you need to learn when you're working with files is the triad, right? So I've explained CP just makes a copy of something. This is one way of doing it. But if I can then make a copy of the file, say CP, in this case, let me to move all my number files, right? I have LS, I have 2, 6, 5, 7. Can I say, okay, let me make a copy of these files? Say CP 2.txt, 5.txt, 6.txt, 7.txt. Say, I want to make copies of them. I want to put them in my desktop. And I put my desktop as my last argument, right? When I do this, I CP them. If I go to my desktop now, see these files have been copied there, right? And you can check this in your terminal by doing ls desktop. So that the files that exist there. So those are 2 ways at this stage that you use the CP command. To either make a copy of a file and rename it, obviously because 2 files in the same location can have the same name. As we did for test say, we rename the copy test2.txt. Or you can make a copy and put it elsewhere. You don't have to change the names, right? As we did here. Right? Please, I hope that's clear. Please, if you're not speaking, please mute. Yeah. So the sister command to CP is MV, right? So MV stands for move, right? So plus LS now. Right? I still have this one. So now, instead of the same way with CP, the 2 things you can do with MV is to rename a file, right? So the same way I made a copy of test.txt here, if I did the same thing for any file here, I'll be renaming it. Please, if you're not talking, please mute. I could do MV 2.txt, and I want to name it, in this case now, 1.txt. Right? If I do this, I'll be renaming the file. If I did ls, so that 2.txt is now 1.txt. Right? These are your rename files. Okay, one of the ways, usually when you rename it, there are other ways to rename a file in like your terminal. Equally, I could have moved the files. So now I want to move all these number files. I want to move 1.txt, 5.txt, 6.txt, and 7.txt. Say I want to move them to, let me say I want to move them to templates. Okay. I do ls now, you see that all those files that passed as arguments to MV, they are gone. And if I ls templates, see that they're now here. Okay, so I've moved them to another directory. So those are the 2 ways that you'll be using the mv command to rename files in the same directory or to move them. Also, you can do both, right? So you can move the file and rename it at the same time, right? So, but as I use the mv command. So, the third command is the sister to CP and MV, like the dark sister, as it usually joke, is RM, right? So, yeah, in this I usually like to keep my home directory clean. Everything here is usually directory. Maybe I've done some stuff and I have maybe 2 files, maybe they are log files or something. Now I want to clean them up, right? So I would say RM tests.txt, and this will delete it, right? If I do this, I do ls now, that's gone. And if I do the same thing here, rm test.txt, it's gone. So that's what RM is, basically. So that's basically the basics of file manipulation. Obviously, the rest is using text editors and stuff to handle that. That'll come in its separate session, right? For this session, want to focus on the basics of working from the shell. So next step is directory manipulation, right? So you can see I have, I think, 12, 14 directories here, right? Say I want to create a 15 directory. Say the command to use is mkdir, which stands for make directory, right? Say I want to make directory and I want to make my directory PLD. So mkdir PLD, if I were to do ls now, there would now be a PLD directory here. Okay? So just for, let me just make another directory, mkdir PLD2. Okay? At ls now, there are now two directories here, PLD and PLD2. Okay? So I now want to create a file inside PLD2. So I now say touch, right, inside PLD2, PLD2. Okay? And now say I want to touch tests.txt. Okay? If I go to ls PLD2 now, that file is inside it. And for ls PLD, it's empty. ls does nothing. And this is important when you want to delete a directory. There are different commands for deleting an empty directory and a directory that's fuzzy, right? So for delete an empty directory, in this case, PLD, what I have to say is rmdir. Rmdir stands for remove directory, right? And I have to say PLD. If I do that, ls is gone, right? But if I were to do rmdir on PLD2, it tells me failed to remove PLD2 directory not empty. Okay? So you can't use rmdir to remove a directory that has files in it. So that those because Linux everything is a file, that could be a nested directory, that's a directory within a directory, or just files, right? So delete a directory that has files in it or anything in it, it's not empty, right? You have to do rm minus rf and you pass the directory name to it. This is how you delete a directory that has something inside it that is not empty. Right? So if I do this now, and ls PLD2 is gone. So that's the basics of file and directory, working files and directories in the shell. Right? You create files, you copy them, move them, delete them. You can do the same things for directories, right? So you can do cp, mv with directories as well, right? Maybe I should just illustrate that. The same way you did for files, right? Let me clear this. So let's say I want to do mkdir, let me make it PLD and PLD2. Right? Right. So if I ls, they're here again. I can copy PLD to somewhere. Let me say I want cp PLD to PLD3. Okay, you have to pass minus r when you're working with directories, right? So cp minus r PLD3, right? There's a ls PLD3 exists, right? And I can do the same thing. Instead of making a copy here, I can send my copy elsewhere. So I can say I want to move cp. Let me just recall that command. Okay, let me just type it again. Minus r PLD. I want to make a copy inside the PLD2. Okay. Okay. So if I have ls PLD2 now, you see that there's a PLD directory inside. I've copied that command, that directory into this directory. So the same way I can do mv. I want to move PLD. I want to rename it. I can name it PLD4. Okay. If I ls, there's no longer any PLD. It's now named PLD4. And the same way I can move it somewhere else. I want to move PLD4 to PLD2. Right? If I ls is no longer here. And if I ls PLD2, it's now in it. Right? So I hope this is like easy to follow. I try to make this easy to follow. Right? So please, if you are with me, please let me know. It's too quiet. This is a lecture. It's supposed to be a PLD session. Right? So let me clear this again. Hello guys.
Yeah, I wanted to ask you a question.
Hello. Yeah, please
Yes,
go ahead.
we can
We
hear
are
you.
following you, sir.
Yeah, I can hear you.
I
Okay.
wanted to ask something like when you are moving something, what's the purpose of putting a slash at the end? Like, do I always have to put that slash?
I didn't get that, please. When I'm moving something, like, are you talking about something like this?
Yes.
Okay. This is to avoid it's something that will happen to you. You make a mistake. This is just to specify that you are moving. You are not trying to rename this directory, right? You want to pass it. You want to copy it to a directory named PLD2 because it's possible for that there was a file named PLD2 somewhere here, right? Obviously not the same location, right? And to avoid that, you want to just be clear to your computer that you want to copy this file or directory into another directory instead of overwriting an existing file or directory, right? You don't want to rename it. This is why you offer something like this, just to be
Okay.
clear that this is a directory and not a file. So if you're moving, for example, a file now, let me just show you. Right? So let me see the two, I think, templates, right? No, is it templates? What file? Let me see. I can see the two templates. I can't remember which was which, right? Right? So ls. So if I do cat1.txt is empty. Okay, yeah. So these are the files that have text in them. Cat 5, right? Cat 6, right? Cat 7, right? Okay. So if I had to move 5 now, the file that's called 5.txt, the only thing inside is the number 5 because it was created using echo and writing the output to a file. So if I did mv 5.txt to 7.txt, right? It will overwrite this file
Yes.
with the content of this file, right? So now if I do cat 7.txt, it's just 5 because ls there's no longer 5.txt. Because when I was renaming this file, the destination of parts, what should have been like the new name already exists. So it will overwrite any file that exists there, right? So it's to avoid this mistake
Okay.
because you will make mistakes when you're typing. Maybe typo, you miss a key string, you miss a keystroke, you're trying to tab to autocomplete, you miss it. You want to specify that for this mv command, the last parameter argument, which is the destination, is a directory and not a file, right? To avoid overwriting something, right? That's why usually you have to say something like that, right? I hope
So,
that
so
answers the
you
question.
only when it is a directory, not a file.
Yeah, yeah. So that's it's old. When you see if you do something like this now, if I go here now, let me just see, right? If I do ls now, then let me create a file here. Let me touch tests. Okay. If I do ls here now and I do ls minus f, see that all the directories have slashes after them, right? But test does not. This
Yes.
is just a shorthand way of telling your terminal, your shell that this is a directory, this is a directory, this is a directory, but this is not, right?
Oh, yeah.
Yeah. So usually when you see anything that ends with a forward slash, is a sign that it's a directory, right?
Yeah.
Yeah.
Okay. Thank
So
you.
that's
Now
usually
I
why you see
understand.
some commands. Yeah, just past that. Yeah. So I'm gonna reset this. Yeah. So we covered the basics of navigating the file system and handling files and directories. So the next thing you want to, I think the next thing you should move on to is create. No, you know how to create files, copy files, move files, delete files, and directories. Yeah. So you've seen me use a couple of flags recently, right? If I should do history, right? You see that I've used, this is a flag, rm minus rf is, they're passing options Options flags are options that you pass to a command to modify the behavior. So in this case, rm deletes a file, right? When you do rm-rf, R stands for recursive, F stands for false. You can use it to delete the directory, right? CP-R again stands for recursive. You're using to copy a directory with all the contents, right? You are changing the behavior of the CP command and the rm command with the flag, right? ls-f changes the behavior of the ls command and has it append // to the end of a list, right? Each item in a directory if it's a directory, you have a / after it. So these are flags, right? So sometimes you want to change the default behavior of your commands, right? So it's called, you need to do that is create an alias, right? Say for example now, I want to say a command. So I want to type hello and I want to say bonjour. So if I say hello now, there's no command here, right? But if I do alias hello is equal to bonjour. Actually, this won't work, right? But just the same. Okay, let me change this to echo bonjour. And will this work? Hopefully. Right? So if I say hello now, say it says bonjour. This is because I've created an alias. Every time I send hello, and I can check this by saying alias. If I say alias, it says all the aliases that I've created. Right? And in this case, you see hello, it's echo bonjour, right? So in this case, every time I send hello to my terminal, in my terminal, it's substituted for this value. So I type hello in and I hit enter. This value is substituted, and the shell sends echo bonjour to the kernel, and I get back bonjour return. In the same way, you can modify your existing commands. So for example, now you see that ls is alias to ls color auto. That's what gives you the color when you do this, right? So if I had to do something like this now, if I had to do touch on that file, let me say touch, for example, just for lack of a better word, hello.py, right? So py is the expression for a Python file. When you get to Python, you see that. But now I want to do something. I want to change the permissions of this file. So chmod +x hello.py. Before I do that, let me just ls, right? So that it's still white because it's a file. If I change the permissions for that file and make it executable, and I say hello.py, when I do ls, it's showing as green. So binaries, executable files, they show as green when you have ls color auto. This color auto is what is colorizing the output, not ls. So if I was to on alias ls, right, and I did alias now, see that the option for ls is equal to ls color auto is no longer there. So when I do ls now, everything just comes out white. There's no color, right? So the color is not coming from the ls; it's coming from the flag. Color is equal to auto, which has been alias to ls. So when every time I was typing ls earlier, this was what my shell was sending to the kernel, and I was getting colored output back because of that, right? And if I copy this, right, and I send it again to the shell, I create a new alias. And when I do ls, I get color again, because there's an alias now for ls that is saying every time you get ls, substitute for this string, or this string, because it's a string, right? ls, and the flag is color is equal to auto, right? There are other options for ls. Let me just do this. The other options is not important. There's always the other ones, but in this case, we want auto. So that's what. So depending on the nature of the file, blue for directories, green for executable files, and white for plain text files. Right? Plain files, not just text, right? It will show this way. It makes it easier for you to understand what you're looking at in the shell, right? This is the default behavior of ls, but usually you have this alias, even if you don't do it yourself, your distribution that you're using, in this case Ubuntu, usually has this, right? Does that make sense? Hello, please, guys, chip in. Hello, guys.
Hello, Mr. Adewale.
Yeah, please, you follow. Do you understand what's happening? That was a heavy sigh. Hello, guys.
Hi,
Hello.
hi.
Hey.
Are you guys
Well,
following? So this is supposed to be a PLD. With some interaction from you guys. It shouldn't just be me just giving a lecture, right?
Yeah. True.
So
I think one thing that you can do is, if possible, you can also try and call out random people and ask them questions.
should
I mean,
like dancing.
you are here to have
Yeah,
you are here to have a discussion, and you are all keeping quiet
sure.
to learn. See, the problem I have
So
is that some people will leave this session and go back and feel like, oh, I need to go and spend extra time to learn these things again. But there's the
Okay.
point in time where you are supposed to grab it, such that when you are
that
going, you are not going to spend
opportunity
another time.
so if I
Ask
was
all your
you,
questions,
I see
discuss.
anything I don't
Like,
understand. On this screen now, there are things that you've never seen before that you should ask. It seems strange. You should ask, what does this mean? Why is this way? What does this mean? Can I do this? What happens if I do this? At this stage, unless you have experience working from the command line, you should be seeing new things and you should have questions. So it's a PLD. Feel free to ask questions.
Can I ask?
Go on.
There was a command that
Yeah, you can ask the question.
before. You had there was a flag was the command was RF followed by RF. What did the F stand for?
You have a lot of echo.
F stands for force. And yeah, so yeah, everyone echo. But you're talking about RM. Let me just briefly straight. Right? So when I was deleting the yeah, I'm talking about this RM minus RF. Let me just scroll up again. Yeah, I'm talking about 620, right? This.
Yes, it's the one.
So the R stands for recursive, the F stands for force. So the F stands for force. So that's a good question, and I think I'll just use that to segue to this, right? So let me just clear this reset. So nobody knows all the arguments or all the flags or all the options for a command. So that's a good question, and you can always check by checking the man page for a file. Right? So there are two ways to check the options for a command. So for example now, like your example, RM, you can do RM $help. It gives you some ways to use the RM command, right? Sorry. Yeah. So you can see RM, and in this case, the first option for you is -F. This the short option and the long option, they're the same thing, right? And it says RM -F is false. Ignore non-existent files and arguments, never prompts before every removal. So this will force removal. Normally, if you want to delete, and I want to show you that after this now, if I was deleting a directory that had files in it, and I did not pass the F flag, I will show you what will happen, right? But this is how you check what an argument is, what a flag is, and what it does, right? You're working in the shell. You can know everything. This is the short form, but the full form is the man page. Manual is manual. We call that man. So you can say man RM, and you get the manual. So you see RM remove files or directories, and this is the synopsis. This is how you use it. The flags are called options. The file you want to delete, and this means more than one. Means as many as you want, right? So it's 3 dots. So you can say option, file, right? So yeah, these are the options you can pass to the RM command, right? So -V, verbose, dir, directories, right? So RM, if you want to use RMDIR, right? This is how RMDIR is. RM is RM with DIR. So I like delete empty directories. The other options, most of them you don't need them, just need a few. Right? So if you want to delete a file, -I, and I'll show you that now. So I'll show you -I and F as options for RM. So if I quit this, right? Let's reset this and ls. So I want to delete this file now. Hello, right? I want to say rm -I for hello.py, right? And let me just create another file first. Let me touch hello2.py. Right? So if I want to delete this file now, and I say rm hello2.py, it just deletes it. It doesn't tell me anything, right? Just deletes it and it's gone. I have to do ls to see if it works, right? But I cannot change these options. I want to delete tests now. I can say rm -v for tests. And when I delete it, it tells me remove tests. I don't have to do ls now because -v flag tells me what the command has done. It doesn't work for all commands, but it works for cp, rm, mv, and a few other ones, right? So the I flag stands for interactive. If I want to delete hello.py now, and I say rm -I hello.py, now I enter now, it's going to ask me, rm, remove regular empty file, hello.py, and I have to type, if I say n, doesn't delete it, it's still here. If I recall the command, and I say yes or y, it deletes it. So this is an example of, I've showed you how to change the behavior of RM using two flags, V and I. I stands for interactive, V stands for purpose, gives you, and it tells you what your command that you've done, if it works. If it doesn't work, it will tell you, right? It just tells you remove test. In this case, you have to confirm. So for -F, right? So there are files in PLD2, right? PLD3 is empty, right? PLD3, right, is empty, right? So if I want to delete PLD3 now, I can just say rm -d PLD3, right? ls is gone, right? But if I want to delete PLD2, if I say rm -d PLD2, it says cannot remove PLD2 directory empty. So now I have to add the R flag. That stands for recursive. Recursive means go into this directory and do it again. And in this case, you are deleting. So you go to directory and you delete it again. If the end directory is in that place, you go into directories and delete it again. So that's how you delete a directory that has files. You just recursively delete the contents. So I want to do rm -dr, right? That means you're deleting directories and you're going into them, right? So I do this now. You see, it deletes everything because there's only one level of nesting, right? Inside this, inside, right? But if there are files there, for example, now, let me just mkdir PLD2 again. Right? Okay, let me just show you another flag for mkdir. So the same way you can change the behavior of mkdir, right, with a flag. You can say mkdir, in this case, I want to use -p, right? -p stands for parents. So I want to create a directory that has files inside, directory inside it. Say PLD, inside PLD, I want to put PLD2, right? Right. So I've created this down, PLD, and for ls PLD, here's the directory inside. So now I want to create a file or files. Let me say I want to touch PLD/tests.txt, and I want to create PLD/PLD2/tests.txt. Okay. If I to ls PLD now, it's the directory and the file in it, and it was to ls PLD and PLD2, that also has a file in it. Okay. So if I was to rm -r PLD now, okay, it gives everything. Because none of those files have Okay, actually, I probably showed you that. Let me just retrieve this again. Let me create this first. Let me run this. Right? Yeah. So let's go into this now and say, let me see the PLD. I want to show you why the force is necessary sometimes, right? If I do ll test.txt, right? So this file is just read and write, read and write, read and write, right? Let's say the file was a file that did not have write protection, not have write permissions for, right? You could not, you did, like, this means that you will, I have to read that today. This is 3 groups of 3. This is 1 group of 3, another group of 3, and this is another group of 3, right? This one is something else. But RW dash RW dash R dash dash means me as the user, as the owner, I can read and write this file, right? Anybody in my group can read this file. This is 3, right? Then anybody can read this, right? Does that make sense? You learn about user groups and owners groups and user later, right? So some files you don't have permissions for them. If you want to delete them, you need some flags. You need to force it, right? Can you guys hear me? Hello.
Yes, we can.
Yes, we can
Okay.
hear you.
Yeah.
Okay.
Yeah.
So in most cases, usually you don't need to manage a flag. But when you're working with usually directories that they have permissions, and some of their files have permissions, right? That's when you need the manage flag, right? So I want to create a file, for example, and a directory that you need the permissions for. Okay?
Hello, please can you hear me?
Yeah, I can hear you. What's your question or your contribution?
On one occasion, you used reset to clear everything on your screen. Is it the same as the clear? Reset.
It's kind of, but it is not, right? It is kind of, but it is not, right? So you can clear your screen in different ways, right? You can use clear, right? You can use reset, and you can use the keyboard shortcut Control L, right? So they kind of do slightly different things, but in any case, you get a clean, depending on your terminal anyway, sometimes it just takes it down, right? Some they don't clear the screen, they just move your viewport down. But the point is that you want to have a mostly clear terminal or viewport so you can type, right? So they do slightly different things, but more or less the same thing. Does that answer your question?
Thanks. My second question.
Okay.
Is it possible to copy? Hello, can you hear me?
Yeah, I can hear you.
Good. Is it possible to copy one file to 2 locations or 2 directories? For instance, you have PLD1, PLD2. Then you have file.txt. Let's say your home directory. Can you copy file.txt to both PLD1 and PLD2 directories?
I mean at once?
Yes, at once. One command.
You want command?
Copy one.
No, it is not possible because the way that the CP command is, let me just show you what man CP is, right? So this is the format for using the CP command. Copy. The option is the flag. And you see it is source and destination, right? You can invert it and put destination first with -t, but it's only the source that can be multiple. The directory cannot have, because it doesn't have this dots, that means there can only be one destination, right? So you cannot do that. You cannot copy one file to 2 places at the same time. But there's a way to do it. And let me just do this before I forget. Right? So, for example, I have a file now. I touch test.js. Right? So, I want to copy this test.js into templates and desktop. Right? So I can do, if I do cp test.js, right, to desktop, right? I can't then say templates here, right? This will copy both test.js and the desktop directory. Actually, it would do that, right? It will give me a error because I'm not passing the -r for desktop into templates. So the way to do this is called chaining. Chaining is the way to run multiple commands at once. So I can do cp test.js. I can pass a semicolon and then say cp test.js to templates, right? So this will run this command and then run this command, right? So this is where you can copy a file to multiple destinations at once. It runs one command first and it does it again. This is equivalent to doing this and then doing this, right? If I do this now, an ALX desktop, see that test.js is not here, and if ALX templates, see that test.js is not there, right? The only way you can see for chaining is something like this. You can see something like, let me just create a file, cp hello.js, right? You can something like this, cp hello.js to desktop, and see this cp hello.js to templates, right? It's more or less the same thing, but it's different. It's a different kind of chaining. This is conditional chaining, right? It's only going to run this second command, or you can chain multiple. I can do cp hello.js to, let me put it in public, right? This is conditional chaining. It runs this command, and if it succeeds, it runs this one. And if it succeeds, it continues around the chain. But sequential chaining is different. Even if this fails, it will do this, right? Even if this fails, it will go to the next one. But this one is conditional. It's only if this succeeds that it will run this, right? And if I run it now, because there's no error, it copies everything. So maybe I should do this instead. Let me just touch. Let me say hi.c. Right? So I'll show you with login, right? Let me say cp hi.c to desktop, okay? And cp hi.c to templates, and cp hi.c to public. Okay? So I want to add the -v flag every time. So you see -v. Okay? So you see that it runs the command 3 times. It copies this to this, this to this, this to this. This is conditional, right? But if I made a mistake somewhere now, right? Let me say this now. Maybe I set it to a directory that doesn't exist. Maybe I made a typo. That's a template. Okay? See that it doesn't do public because this failed. This second one, first one went through, the second one failed. It doesn't run the third one. That's why it's called conditional. It's conditional on the previous command succeeding before running this one. So does that make sense? So that's just to explain the different types of chaining. This is sequential chaining. Doesn't matter whether the first part fails, right? This will run. You run this, even if it fails, it will jump to this. But this will only run if the previous command succeeds. So because this one failed because of a typo, this did not run. So yeah, that's how you can copy one file to multiple locations more or less at once. But to the shell, it's the same. You're doing it as separate. If you're doing it this way, you're doing it as separate commands. This way, you're doing it conditional. As run this command if this one passes, run this command if this one passes. Right?
Yeah.
Yeah. So back to, go on.
I'm sorry. One more thing. I noticed that sometimes when you type a command and you don't want to execute it, you do something and then it leaves the prompt. I don't know what you do, but for some reason you don't execute.
What do you mean? What do you mean it leaves the prompts?
Okay, where you have the $sign, for instance, you type the cp hello.js desktop / ncp. You didn't execute that command, but for some reason you got an empty prompt as in the $sign came and then you typed another command. So in case you type something you don't want to do, but you want to just get
Okay,
rid
I want
of
to,
it.
okay, something like this now. I want to now go to the beginning of the line. That I was talking about.
Aha, but you don't want to delete everything and waste time.
Yeah, I
But you
can
want,
just jump to the beginning of the line like this. Is it what you're talking about?
yes.
Oh, there's a
Or
keyboard shortcut for that. It's
let
Control and A
everything.
to jump to the beginning of the line, and Control and
Okay.
E to jump to the end. If I want to clear everything, I can just do Control and U like this, right? And if I want to bring it back, Control and Y, right?
Wow.
There are keyboard shortcuts for that. I don't want to go into keyboard shortcuts, but there's a
Okay.
resource on your curriculum page or concepts page called I can't remember the name, something about shell. It goes into detail about all these keyboard shortcuts. But for now, I just want to cover the concepts, right? Keyboard shortcuts are for making you do work faster in the terminal. But you have to understand the concepts first so you can apply them better. Right? Yeah. Okay. So where was I? Before I forget. Okay. CD. Why we need to use RM minus RF sometimes, right? Yeah. So yeah. So if we do ls now, there's a file and a directory here, and if we
I
do
also
ls,
have a question.
okay.
Can you talk more about echo? I was hearing like you saying you cannot use echo to create a file, something like that.
Yeah. So if you man echo, right? Echo is it's what echo does. It just displays a line of text. Echo cannot create a file, right? Echo just prints. Echo is just like printf, and indeed you can use printf in shell as well, right? So if I say I want to echo good evening, right? This is what echo does. It just prints whatever you pass to it, right? That's what it does. But if I want to now add this to a file now, right? I can say good evening. I'll redirect to a file to say creating.txt, right? So it is not the echo that is creating the file, it is this redirection operation that's creating the file. Right?
Okay, understood.
Okay, yeah. So if I do this now and I cut creating.txt, right? You see text inside. So it's not the echo that is doing the creating. Echo is just printing. You are now redirecting the text stream. Instead of putting it to your screen, you are redirecting it to a file. So echo doesn't create a file. Cat doesn't create a file. It's just the redirection operation that is doing this. Right? Okay. Yeah. So yeah, what was I saying again? I forget. Please, someone remind me what I was saying. My memory is not what it used to be. Hello, somebody tell me where I was.
Something about RF.
Okay, yeah. So RM minus RF, right? So yeah, yeah. So yeah. So try ls here. There are files and directories, right? Yeah. So sometimes I want to recreate a situation where you're using just RM minus R, which we've used before. Like do history. We did RM minus R somewhere. Yeah, we did RM minus R here, and it worked, right? It deleted the directory. And so now I want to recreate a situation where that wouldn't work. Right? So all we need to do is hold on. I can't remember what the exact cases. So usually you would see where is this? So let's do LL here and see the permissions for this. We already agreed. And yeah. So let's say, for example, now this migrating your text, and I added the permissions. I say sage mode plus X. Usually for directory, right? I want to show you, right? Sage mode plus X, greeting. Let me do it for the top them and for PLD too. Okay, so greeting.txt. Right? So if I ls now, oh sorry, ls, yeah. You see that written dots. If I do ll, so you can see that better. So that both the directory and the file now have execute permissions for user, group, and owner, right? So, yeah. And yeah. So if I was to come out of here now, let me just try it here. Let me try to do rm minus r PLD2 and see if I've recreated what I want to recreate actually. Try to delete it, interesting. What was supposed to be? Oh, sorry, there should be something. I think there should be something inside this. Let me do mkdir PLD2. Then let me touch. Let me use echo to create a file PLD2. Hello. And let me do. Yeah, so I think this is a directory. Let me just be on the short side. Let me add permissions to that file. So usually a permissions issue that causes that thing, but I'm not sure exactly how to do it. So what the situation is PLD2 hello. Yeah, say like LL. Yeah, I think this is the perfect. I think right. So if I try to rm minus, let me come out of this cd ls xpld. Let me just try to do chmod plus x for PLD as well. Let me see if this will work. About rm minus f PLD. I hope this recreates my bug. Yeah. Sorry. I'll be doing rm minus r, not rm minus f. What did I do up here? Yeah, rm minus r. Let me see if it works. It actually works. I can't remember what the problem is. But sometimes it won't let you delete it, right? I'm trying to remember what it is exactly. I'm trying to remember what causes this problem. Why you have to use the force? Because f starts with force, right? Sometimes rm minus r doesn't work, so you have to add the force to make it work. And I'm trying to remember the situation that causes that problem, and I can't remember. I'm trying to remember. Just hopefully I remember later. But let's just move on. But that's basically why you need the f flag to force the operation. Obed, if I remember why we need to use rm minus f, please chip in if you have it. Yeah. So I think we've handled aliases, file manipulation, key navigation, and we've touched on redirection, right? So with echo. So let's cover redirection. There are two. So for example, now if you have ls, if you cut hello.js, right? It's an empty file. But if I was to do something like echo console log hello, right? Okay, this is give me an error. And I redirect it to hello.js, right? If I were to cut that file again now, that text is inside, right? Just to explain to you that redirection is what moves the text from outside to inside the file, right? And if I want also, I can redirect text from outside, from inside the file outside, right? So I can do something like, I think echo hello.js. I hope this works pretty well. It doesn't, what I just do? Cut hello.js. Yeah, it's inside. How do we redirect text? Outside again, I can't remember. So you can move a text from redirection doesn't always work one way. It can do it the other way as well. How do you hold on? Okay, let me just go there. But the thing about redirecting text one way is this. If I wanted to add something else, another console log statements, say, let's see, I can use to this now. Instead of adding a second line to this file, it would overwrite it. So if I was to do cats, instead of having hello and then bonjour, you overwrite it. So you can do this by appending instead of so you change this to 2 greater than signs, right? Instead of 1. And instead of overwriting, you add it, right? So you now see 2. So that's redirection. You can redirect to a file and you can append. So this will also create the file if it doesn't exist, but it won't overwrite the contents. It will just add the line of text or whatever block of text you are redirecting to that file instead of overwriting it, right? So as redirection. Another thing is piping, right? So say something like
before you
yeah?
move on, can I ask something?
Okay.
Why did you put that console log in those commands, like those explanation? I don't know what to call it.
So this is a way to tell. This is called this is a string, right? In programming, a string is a sequence of characters, right? And you can have strings that are multiple words. So for example, you want to do something like this. You can say echo hello, right? Because hello is one word, right? You can do echo hello, right? It doesn't make a difference because it's one word. But if you now want to echo a string that's more than one word, say hello world, right? Echo will handle this. Some other programs would not, right? So usually what you do is you put it in a string, right? Right? So that everything is passed to the command as a single argument instead of multiple, right?
Oh, okay.
Does that make sense?
So if it is more than one word,
yeah, and you want it to be sent, everything to be sent together. There's something called globing. That's like more advanced. That will break up your arguments into different. You break up this string into different words, into different tokens, right? But you want everything to be sent together. You put it in a string, right? So you can see this now. The reason why I had to use single quotes for hello here is that inside this function, you know, to code JavaScript, you have to pass hello as a string as well. And in JavaScript, single quotes and double quotes, they don't make any difference. But if I had used double quotes here, this would have been one string, right? And this would have been another string. This hello would have been lost. So that's why I did this, right? Okay, so I'm trying not to get ahead of myself and just stick to the basics, right? So maybe that was a bad example, right? Yeah, so that's redirection. This is something called a pipe, right? So for example, let me just quickly, so let me say man ls, right? If you man ls, you can redirect this to a file, right? ls.txt, right? So this file now contains the manual for ls. So if I was to do, this is a good example, right? So let me open this file, nano ls.txt, right? It contains the full manual, for the ls function. It's not too long, right? So yeah, 217 lines, right? So you can check the length of any file by using the word count WC, right? And yeah, so it's 215 lines, right? They don't count the white spaces at the end, right? So if I want to check this file now, and I forgot something, this is a good stuff for telling me. If I want to read this file now with cats, if I cat ls.txt, it's going to print the whole file to my screen, all 215 lines, right? Which doesn't make sense. Maybe I have to check something inside that file to continue my shell, but it has scattered everything now. So there are two commands for handling large files. The first one is less, right? So you say less ls.txt, right? And it opens it, but it opens it in a buffer. just like when we were checking the man page. So you see, it's not a full text. You can then page through it by hitting your spacebar, right? And you go through it page by page, page by page, page by page. You can press H for your options, right? Say Q to quit, you know, any of these expressions, Q, Q, capital Q, ZZ will quit, right? And you can do this inside. So if I do ZZ now, it quits. But you see that I've been taking one line of text in my terminal. I continue to do what I was doing. Instead of cuts that I've printed everything out, right? So in the same vein, there's also more, right? It does more or less the same thing, but it handles it slightly different. You see, it's telling you that you've checked 15% of this file, right? And I get it 28%, 44%, 58%. It's just giving you like a percentage of the file, or your current position where it is in the file. Okay? So yeah, and when you're done, but the problem is with this, when you're done, it doesn't clear your screen. That's why more is kind of annoying, right? But less is just one line, right? So when you start handling bigger files or files that you don't know how big they are, right? And you just want to check something, you use less to open them. You open them in a buffer, right? You don't open them into your screen, right? So pipes. Why I actually created this file is this. This is a file that is 215 lines long, right? Let's say I want to check for something inside this file, right? So I could open the file. I could say nano ls.txt, right? And I could look for what I was looking for. Say, for example, I'm looking for reverse or commas. Let me look for commas, right? I could search for it with my eyes, like I would normally do, but that's not the best way to go about it. So what I could then do is this. I could then search for this. I could search for grep commas inside this file.
Sorry, before you move on.
What?
I want to ask something. Is nano a command?
Okay.
Is nano a command just like man when we type? Man,
No. Nano is just like Vim, right? It's just like Vim or Emacs. The text editor in your command line, right? So let me just show you, right? So this is my terminal. I've kind of configured it, so it's different from what you usually have. So I have Vim here as well. Wait, why do I have a C file here? Okay, sorry, this is here. Blah, blah. So if I open your ls.txt now, you see it's different from what you know. That's why I don't want to confuse you. That's why I'm using nano, right? Right? So my Emacs is the same way as well. If I said Emacs ls.txt, okay, I've not opened this today. So that's why I don't want to confuse you, because I've configured them, right? So that's why Ctrl X, Ctrl C. Yeah. So that's why I'm using Nano. Nano is the only one that is simple, right? So it's the same file you're opening with a different interface, and this is what they want you to open. So that's why I was just like not showing you this. So I'm using a different terminal, like just like vanilla, right? Yeah. So Nano is just like, it's a text editor, just like Vim, right? Version, right? So it's just a text editor from GNU, right? Simple. It's kind of like Emacs, right? But it doesn't have too much configuration about it. So you can just open it and edit your file and close it. Then it's beginner friendly because it has the commands to use, right, at the bottom of your screen. So if I want to exit, it's Ctrl X. If I want to read a file, so I want to copy and paste, it's Ctrl K to cut, Ctrl U to paste. The commands are at the bottom of the screen. So many people like to use it when they are new to terminal. Unfortunately, ALX doesn't give you this in your sandbox. You have to choose Vim or Emacs. Yeah, so that's what Nano is, right? It's just a text editor. I'm using it in place of Vim in this session. Yeah. So, as I was saying, if I want to check for a word in a file that is 200 plus lines long, I can scroll through it, and hopefully my eyes are good enough and I can catch it. But the best way to go about it is to use a tool. In this case, I want to use grep. So I want to search for commas in this text ls.txt. Right? So this will return the line where it was found, right? It just says me this is the only place where commas shows in that line, right? Just returns the line anywhere the commas is found, it will return it. Say I want to look for a word that is more common, like say let me say reverse. See, reverse shows in 2 lines, so it prints the lines that occurs in that file, right? So maybe maybe I need the line number or something, right? So or maybe I need to look around, right? So maybe I don't know. I think maybe I just need the line number where that happened. I say, okay, I need the line number. Let me just check, right? So this is another issue of flags. So you can man grep, right? And check, say, okay, these are the options, minus V, minus F, right? Minus I to ignore case, because by default, when I do something in Linux, this case is case sensitive. So file with the capital F and file with the lowercase f, they are 2 different things to Linux, right? So in this case, I can say, okay, say I want to print lines without match, like files without matches, right? So there are options you can take. So minus n will give me the line number, right? So let's say Q now. I say I want to see what line this commas is. I can just say grep minus n, right? And tell me that this text that I was seeing before is on line 55. Maybe I needed to copy this thing or something. I can go to line 55 in that text and get it out. So this is an example of a command. So just imagine now that I wanted to do something with this text, right? I could, now that I know the line number, I could then go inside the text and maybe copy it. Maybe I wanted to copy it to a file, right? Let's imagine that I wanted to copy this, just this line to a file. And maybe I need this for ALX or something. I need to push it to my GitHub as the answer to a file. I have one way of doing it is to run this, right? Then I come and say, okay, the text exists in the file. I could then come and run this. So it's on line 55, and I could open the file, say vim, I don't even have anything vim, nano ls.txt, right? And I want to go to line 55, right? Right? I want to go to line 55. My line 55. Why is it not going to interesting? It's not working. Right? 55, and I could copy it, right? Yeah, so line 55. It's actually line 56 because it starts from 1, right? So I copy this. Maybe I just copy this now. Copy this text, right? And I go and put it anywhere I want to put it. No. So the better way to go about it is to use a pipe. A pipe is this. This is a pipe, right? A pipe is whatever is coming from this side, we are passing it to this side, right? So you could use the output of one command as input to another command. In this example, I want to get this line. Right? When I run this, this is the output of the command, right? I could then use this as an input to another command. So I could say grep this, and I could then say this thing that's coming from here, write it to text for me, and I say commas.txt, right? And if I was to cut commas.txt now, what's it? Interesting. Why is it empty? LS first. Why is cut? Why is commas.txt empty? Interesting. Should have piped this and try it again. It's not piping. Why not? Interesting. Let me just do it. Oh, sorry, I missed the first part of the pipe. The first part of the pipe is to actually cut the file, right? Cut ls.txt, right? Then grep for what you're looking for inside, grep commas, right? And then pipe that to this file, commas.txt. Right? So if I cut commas.txt now, why is this empty? That's odd. Wait, hold on. There's something wrong with my pipe. Nope. It gives me, why is it not piping? Actually, I can just do this. I think this is the problem. It's the pipe and redirection. Commas.txt. Right, so if I cut this now, yeah. So this is an example of a pipe. This is a simple pipe, but you can now get into more complex piping when you are filtering and doing stuff, right? And maybe I should do that right now. So I've run a command cat ls.txt, which prints this command. But instead of now putting it to the screen, I'm now searching through it for commas, like the line that has commas, and redirecting the output of this to this. So pipes and redirection, they kind of go together. There are operations where you are taking something from one command or something, and you're sending it somewhere else. That somewhere else could be a file, as we've done here, right? But it can also be to a location or something else, right? So this is an example of pipes and redirection. They usually go hand in hand. So let's say, for example, now I wanted to do something with this, right? Before I wrote it to a file, right? This is what it gets. I cat prints the whole content of the file. I search for the line that has commas. Maybe I don't want the whole thing, right? I just want maybe one word. Maybe I want, I don't know, single column. Maybe I want single column or single or horizontal, right? I could say cut. I want to cut this. Say minus D. What do I want? I want this to be the delimiter, right? That means that everywhere you see this, cut it, right? So, right? I say minus F, right? This will be 1, 2, 3, 4. Wait, hold on. Let me just pass a number first. Let me say 5, right? You can see 5 is L single, right? So this is 1. This is 2. This is 3. This is 4. L single is the 5th field, and I return that to me, right? Or maybe I just want horizontal. Let's say I want horizontal now. I will say this is 1, this is 2, this is 3, right? So let me change this to 3 now. It won't give me what I want, but I'm close. I'm now at M horizontal. I could then pipe this into another cut. I say now I want to cut minus D, right? I think the default is space, but let me just put space, right? And I say minus F2, right? It gives me horizontal, right? So this is a pipe. The first part is this. I pipe it into this. I pipe it into this. Then I pipe it into this. So this is a pipe with a pipe operation that has 3 pipe operations. This is first one, second one, third one. I could then pass this to a file now. I could redirect this to a file now. I could say axis.txt, right? And so I cut that, right? It's horizontal. So this is pipes and direction. It's a more intermediate stuff, but since you guys are already doing it with your echo and your cats, let them just explain that, right? So yeah, I think those are the basics of working on the shell. The last thing you want to do, since once you're familiar with commands, you know how to use commands a little. The next thing is scripting, right? Say for example, this pipe now, I could create this into a script, right? So let me copy this. It's okay, a good example of a pipe or a script, but let me just another example, right? Let me say Control U to clear this, right? You want to do something. You want to say echo happy birthday, right? And you then want to say I don't know. Let's say you want to sleep for 5, right? Sleep for 5 seconds, and then you want to say echo hooray, right? Around this echo of happy birthday, my screen is only for 5 seconds, and then it prints hooray, right? So instead of doing this, I would have written these commands in a script. So I want to say nano hooray .sh. Okay. So let me just do this. Call this a bank. Let's say bin bash, I think. and I say echo happy birthday. Right? I say sleep for 5 seconds, and then echo hooray. Save this, and I want to make it executable. chmod plus x, right? And I run this. So it runs the first command, waits for 5 seconds, and it runs the second command. So that's what a script is. A script is basically a sequence of commands that are run, usually one after each other, but you can also have conditionals. That if this is this, do this, if not, do that, right? So that's the script. This is the same thing as this, that you have this and this are the same thing, right? So it's the same commands, but instead of training them, I can actually chain them in the script as well, but just to illustrate how they work line by line, this is how they work. So you can do this. You can also take, for example, I could have a script that says, let's say I want to name this nano. Please, if you have any question, please ask. Greeting sh, right? So you want to add this bin bash, and you want to say let's say echo. What is your name? Right? I want to say read name. Right? And you want to
Can I ask a question?
Wow, you have a tribal echo. Yeah? Right?
Can I ask?
Yeah, ask the question, please. If you have a question, please ask. Yes.
Your first line of hashtag something bin. Is it like any does it initiate something or?
Okay, that's a good question. And it shows I actually follow. So this is called this first part is a path to interpreter, right? So that when you run the command, you're going to make a script executable and get to run it, right? You're telling the shell what program you want to interpret this program for you. Right? It's an executable. An executable is a program that can be run, right? But there are many programs that handle execution, right? When you start doing Python, you use the Python interpreter to run your scripts. If you're doing JavaScript, you use JavaScript runtime. When you're using C, you use create an executable that can be run, right? So different programs will handle different files. So in this case, I'm telling the shell that I want bash itself to run this script for me. That is a bash script, right? And I'll show you just now with Python. Yeah. So in this case, this is a simple script that will read your name. So if I do chmod plus X for greeting.sh, and I run greeting.sh. Say, what is your name? And I say, my name is Obed. It says, hello, Obed. Right? So it's just like Bash is also like a simple programming language, right? It's not a full programming language, but you can do. I just want to show you that you can do interesting things with scripts. You can take user inputs, you can process that input and do things with it. You can take numbers. For example, you can do echo 2 plus 2, right? Will this work? Let's see if this works. Right? So you can do math in your shell with echo. This is an expression. You evaluate it and return the value to echo, and echo will print it. So bash, you can do like some interesting things with bash. You do some of this as you go along. But this is just things. These are just the basics of bash. So bash is both a scripting language. It's not a full programming language, but it has variables. You can do loops, you can do recursion, and it's also like what you know, what bash should be doing since as a shell, right? So just to explain the concept of an interpreter, let me create a Python. Let me say hello world, or hello dot, yes. Yes. Okay. Do I have? Yeah, I think I have node. Yeah. So let me see. And this actually works. So, yeah. Right? So in this case, the interpreter for node is user, I think, bin node, right? In this case. Right? So I want to give it the execution permissions, chmod plus x, hello.js. So if I run that script now, it runs the command. You see that it's because this is JavaScript, right? It uses a different runtime. So if I was to do cat hello.js, this is a different runtime. This is the runtime for JavaScript. It's Node, right? So if I want to do Python now, if I say nano hello.py, right? The runtime for Python will also be different. It would be user in Python 3. Now just say print orange. I'll close it. Right? And I'll do say node.x hello.py. And I could then run that the same way. Right? So you see that these are all three scripts, but they are being interpreted by three different programs. One is being run by Bash, one is being run by Node, which is the runtime for JavaScript, and one is being run by Python 3. Right? So that first line, right? When you say just reset this. Alright. Like I say head -1 for hello.js. So I probably have covered head and tail, but we'll do that some other time. This is Node, right? If I do head for hello.py, right? This is Python. If I do the same thing for greeting, I think, right? So these are all scripts that are being run by different programs. So this is what this line does. You're telling me that you're sure that this is an executable file. You've checked the permissions and you can run it. Now you want to run it. Go and look for this program to run this script for me. That's what it is.
Okay. Thank you.
Right. Yeah. So when you're using Bash, they are often different. For example, if I do which Bash now, this is Bash, right? I see that this is what I was using. But you see, I'm using bin Bash. So if I say where is Bash, I say that this is where Bash is, where it is. But it was working, right? This is Bash, where I did this, right? And it worked. There's the same link. So tomorrow we'll look at some other things I couldn't cover today, like sim links and how to find binaries and head and tail, right? So it's important to know where the program is going to run your script is. And then pass. This is an absolute path, right, to that file. So if I go to if I do ls bin bash now, right? This is bin bash. So this part is just telling this to look in this location for this program, right? If I do ls user bin Python 3 now, right? This is an executable, right? You see, there's a slightly different color. You understand that later, right? So you're telling this to go here, and let me just show you. Okay, just I think it's bin Python 3. I'm not sure. Right? So you see these things are different colors. ls local. Sorry. Local bin yeah, so I'm actually looking for the actual Python. You see this when something is blue like this, let me just show you. Let me do ll right? When it's blue like this color, it's I don't know, turquoise or whatever, it means there is a link. It's not an actual executable. It's just a link to the executable. So this is the place where the actual Python is, user bin Python 3, right? But if you go to that user bin Python 3 now, if I do ll user bin Python 3, right? It's also a link to something else, right? Python 3.10. Right? So this is the actual executable. As you can see, the color is green. The links are greenish blue, right? So the reason why I'm saying this is this. You will see some scripts that have the same bash. Some of them will be bin bash. Some of them will be user bin bash. Some of them something different. It's really still the same program that's running all of them. But some of them are going to a link. Some of them are going to the file directly, right? Does that make sense? So
yes, it does.
So I think we've done 2 hours. That's enough. So tomorrow, before we go into using text editors, we're going to look at links and finding binaries with which and where is head and tail, and I think a few other things. But that's basically what we're supposed to do today. We've covered everything. So let's just take questions, recap, and any other thing while we're here. So you have any questions about anything you've seen today, anything you wanted to ask that I didn't cover, or any other thing, please ask now. Or something that's not clear, or something that you've done in a different way, because you find as you go on in this program that there are often multiple ways of doing things, right? Or anything that I said I would come back to that I've forgotten to come back to, please, if any questions, anything, just let me know. Hello. Hello. Can you guys hear me? It's so quiet all of a sudden.
Yeah, I can hear.
So there are no questions, nothing you wanted to do or you do differently that I've done in a different way, something you've seen that wasn't clear, or something you disagree with, or something I've said I will circle back to and I've forgotten. There's nothing. Oh, okay. So I think we've done 2 hours plus change. I think this is a good point to drop anchor for today, and we'll go again tomorrow.
All right. Thank you so much for the words of knowledge that you have given. I think some people are now joining. I shared it on Twitter and people were requesting for the link, so they are joining. For those of you who missed the session, hopefully by tomorrow evening, this particular session will be available on YouTube, and we'll share the link in the Telegram group. However, tomorrow too, we are continuing the session as Adewale has already said, and we're looking forward to having you here. One thing that I want to reiterate, even though we've been saying it all this while, is that these sessions are PLD sessions. These are not YouTube videos that you go to watch. Okay, so we expect you to come with all your questions. Ideally, we could have just hosted this as a live or a pre-recorded video and published it if all we cared about was to teach or lecture. But then we wanted to give you the opportunity to have a feel of how we practically do these things and get the opportunity to ask, especially knowing that the people teaching or leading the sessions are people ahead of you in terms of the cohort. So you should make good use of the opportunity, and every moment you spend here shouldn't be like the time that you want to come and watch somebody teach you something, then you go back to go and learn. By the time that you want to come and understand the things that you are finding it difficult in the program as you are taking, I encourage you all to prepare very well, especially if you have questions, you have challenges whilst doing your tasks or anything of that sort, so that when you get here, you are able to ask those questions and get answers to them. So, thank you so much, Adewale, and everyone else too. Thank you so much for joining. We appreciate your time with us, and we look forward to meeting you, God willing, tomorrow, same time. tomorrow 6 p.m. GMT. So if you are in GMT time zone 6 p.m., if you are in WAT time zone, that would be 7 p.m. And if you are in EAT time zone, that will be 9 p.m. So around the same time tomorrow, we'll be meeting. Thank you all, and God willing tomorrow. Bye-bye.
Thanks, Doc.
You're welcome. Bye. So let's stop the recording. Stop recording.